Okay, so hi all. I'm here with Professor Avi Goldfarb. Avi, thank you so much for coming. And this is a follow-up interview to the excellent depth talk about communicating uncertainty can increase AI adaptation. So if you have not watched the talk yet, I recommend you first to watch the talk. And I will proceed right to the first question. Can you please explain your findings regarding uncertainty in the AI adaptation to an undergrad student from an unrelated field or even to a layman?
Absolutely. Okay, so there's a lot of excitement about AI in the world right now. Um, if you look under the hood, when you hear people say artificial intelligence, you should interpret that as computational statistics. Okay, sounds a little less exciting, but that is what we're really talking about here. And you know, statistics, when you do analysis, you get a best guess, which is your average or your mean. But you also have some uncertainty around that average. Okay, so when you use stats, there's a best guess number, then there's some kind of confidence interval or some kind of uncertainty around what might, the ways that your estimate might be wrong. And what our hypothesis is in the paper is that one of the reasons why people may not adopt AI is because most of the time when you see an AI recommendation, whether it's from ChatGPT or Uber telling you how long it's going to take for the car to get there, or many other things, they give you just the best guess. They say it's going to be 6 minutes, and that's it. But the reality is that that prediction, that number, has some uncertainty around it. And so our paper is about if we allow people to see the uncertainty, might that lead them to adopt more? And then we unpack different types of uncertainty, and we do this in the specific context of Airbnb. And Airbnb, turns out they recommend prices to hosts, to people who rent out their apartments and homes. And we think about, rather than just suggesting a best price, if they also told you how uncertain they were about that best price, that would lead to more adoption.
Cool, that's very interesting. So, following question based on what you speculated in your talk about Waze. So, what is your best guess if Waze provided you not only their estimated time but also their range? What do you think will happen? Which, Mhm.
I think Waze would be more useful. So right now, when you get directions, they tell you a best guess. Oh, it's going to be 22 minutes. Okay, and it's actually astonishingly precise. They don't round to the 5. They say it's going to be 22 minutes. And but at least my experience is sometimes it's 22 minutes, sometimes it's 20 minutes, and every once in a while it's 40. And I think Waze would be it would be a useful tool to say, look, our best guess for this route, our best guess is 22 minutes, but we're pretty sure it's going to be between 20 and 25. There's this other route that maybe our best guess is 20 minutes, but it may be as long as 40 because every once in a while something goes wrong and it becomes a really, really long route. I think that information would be useful to users. Now, in Waze's context, I don't know if they've experimented about this or thought about it or anything like that. I want to be cautious, but I think in many contexts, providing not just the best guess, but the uncertainty around that best guess would be useful.
That's very interesting. By the way, I think Waze are somewhat cheating because if you're stuck in a traffic, they're just updating your times. They're not saying you that we are wrong. They're just updating it. Okay, it's not 20 minutes. It's actually an hour 20 minutes.
Right.
Luck.
But their model had some prediction in advance that would have said, yeah, 20 is our best guess, but there is some chance that something longer happens, and we as the user just don't see that. And if they
Yeah.
communicated it, like the way we do in our research, when we publish papers or do analysis, we provide both a point estimate and we give a distribution. And so it's an interesting puzzle about why in so many machine learning contexts, so many AI contexts, we don't get that information about the distribution. Some of that is a technical point, that it's extra work in some machine learning algorithms to provide the distribution, but a lot of it is about user interface design.
Yes, that's very interesting. It might be also related, just speculating to information. They don't want to provide too much information,
For sure.
and
For
all the
sure.
issues, how to lie with statistics, like the
Yeah.
way you provide information can.
Absolutely. That can influence how people use it. And so contrasting Waze and Airbnb. So the Airbnb pricing tool, the vast majority of hosts don't use their AI pricing tool. And so it might be worth experimenting with different designs to see if they can increase adoption. Where Waze, plenty of people use Waze. I'm not sure if that's the margin they're focused on. And so this kind of experiment, maybe the point estimates work the way they do it right now works for directions.
Okay, very interesting. And the related question, how do you think your research finding can be extended, especially in the domain of decisions from experience?
Sure. So we ran this as an online experiment and treated each time people were deciding whether to use the pricing AI as an independent decision. And there was no feedback. So people didn't learn whether somebody booked or not. And so the way our experiment was, is currently reported and set up and was in the presentation is there's no learning, no feedback. And so we have some sense of how people, interpret this uncertainty. An extension that we are now working on is to give people feedback. So every time they select a price for their room, the interface tells them, yes, that was booked, or no, it wasn't booked. And that makes the uncertainty, we speculate, more apparent, in the sense that one type of uncertainty is that even if you do everything perfect and you price exactly optimally, sometimes just the person doesn't show up that might be willing to pay that price, and the room remains unbooked. And so, by communicating, we don't know for sure if somebody's going to book this or not. And when that happens, the room may be unbooked or booked. That might we hypothesize that's going to foster trust in the algorithm and make people use it more. We don't know. We're about to take that experiment into the field actually this weekend, and we'll see how it all plays out.
Oh, wow. So first, good luck. It sounds
Thanks.
very exciting, and I'm eager to hear your results. And basically, you speak about two types of uncertainty, right? Right?
Yeah.
One uncertainty in what is the best price, and one uncertainty is whatever it will be booked or not booked.
Absolutely. So I wasn't doing that in the version for the layman, but a key part of the academic contribution to the paper is to try to understand these different kinds of uncertainty. So you can think about some things, call it fundamental uncertainty, as in, just even if you knew just about everything about the world, some things are sort of unknowable in advance. Okay. You can think about these as, before you roll a die, you don't know where it's going to come up, or before you flip a coin, you don't know if it's going to be heads or tails. And in the context of markets, you can have the optimal price, but you don't know for sure whether a person who's willing to pay that price is going to arrive and see the price. So there's uncertainty about whether people buy, even if you've done things, everything perfectly. So we're going to call that fundamental uncertainty, or aleatoric uncertainty. Then there's another kind of uncertainty, which is that this recommended price comes from a model. Okay, and the model has some information, but the model's imperfect. And so we have some confidence around how likely the best estimate of the model really is best, but we don't know for sure. And so there's this other kind of uncertainty, which is that the model might be wrong. There's various ways the model might be wrong. We're going to emphasize confidence intervals, that we just don't have enough data to know exactly what the right number is. And so what we find in the paper is, so far, that when you communicate the fundamental uncertainty, that maybe just even if you do everything right, some people might not show up. That fosters trust and increased use of the algorithm. In contrast, when you communicate the model uncertainty, look, we built this model, but it might not be as good as we'd like it to be. That seems to make very little difference on what prices people choose. And whether people listen to the AI or not. And so we have these two kinds of uncertainty. The fundamental uncertainty seems to lead to increased adoption, but communicating the model uncertainty doesn't seem to make much difference.
That sounds very interesting. Yeah. And not that intuitive, I have to admit. Maybe it is intuitive when you think about it deeper. Moving to a little bit different question. As an expert in the AI, how will AI impact our lives in the foreseeable future? What do you think? And I know it's very difficult to make predictions, especially about the future.
Yeah, so when we
this is a tough one, I know.
Yeah. Well, I spent a lot of time thinking about this question. It's a little bit tangential to the particular paper on trying to understand model uncertainty, but here's how I think about it. So, and this is where so about, what was it? 6 or 7 years ago, we published a book called Prediction Machines. And prediction machines argued what I already told you guys, which is that when we think about AI, we should think about it as statistics, as prediction technology. That's what's going on under the hood. It's using information, data, and filling in missing information. That doesn't make it less exciting than the title of artificial intelligence, but it requires a few more steps. So what started to happen close to 15 years ago with AI tools is people started to use them in good old-fashioned predictions, like whether somebody was going to pay back a loan from a bank or whether somebody was going to make a claim to an insurance company. So it's been at least a decade when banks and insurance companies have been using AI tools, using machine learning tools for these good old-fashioned prediction problems. What's starting to happen over the last decade, and especially over the last 2 years, has been some things that we didn't used to think of as prediction problems. We're realizing we can solve them with prediction. Okay, so things like medical diagnosis, or think about ChatGPT writing, or DALL-E drawing. Like these, you used to think of these as prediction tasks, but it turns out when prediction is cheap enough, we can do those sorts of things as well with prediction. So how do we then, trying to put on a futurology hat, and be careful about this, like how do we expect this to play out? Well,
you are recorded.
Yeah, we're recording, I know. So the first thing is, we should expect predictions to get increasingly cheap. And so we're going to see more and more applications, even in things that we didn't used to think of as prediction. Fine. We've seen that. That's continuing the trend we've had so far. The second is another Econ 101 concept. So that's Econ 101. That's demand curve slope downward. The price of something falls, we do it more. Another Econ 101 concept is substitutes versus complements. Okay. So the aspects of human work and the human experience that are about prediction are increasingly going to be done by machine. In contrast, the aspects of human work and human life that are about generating data, which is a core input into predictions, and that are about understanding what matters, values, the things we call in our book judgment, or what formally might be, if you think about a decision tree, it's the payoffs at the end of a decision tree. That is increasingly important and increasingly human. So one just thing to think through is, here's this technology. We're going to see less of the substitutes, more of the complements. That was the Prediction Machines book. And then a couple of years ago, we had another book come out called Power and Prediction. And the theme of Power and Prediction is that of the technologies out there right now, the new emerging technologies, AI is the most likely to be a general purpose technology. Okay. Now we're moving a little bit away from decision theory and moving into IO and the economics of innovation. Mm-hmm. And so when we think about general purpose technologies, what we know from electricity and the steam engine and the internet and computer is the impact is always smaller than you think in the short run and bigger than you think in the long run. Because effective use, application of these kinds of technologies requires reinventing how sort of organizations operate. And that takes time. And so Paul David and Warren Devine Jr. have this great example of how factories electrified. It was originally in a 1983 Journal of Economic History paper by Devine Jr. and then sort of applied to computing in 1990 by Paul David. Robert Solow, the New York Times Book Review, talked about computing and said, we can see computers everywhere, but in the productivity stats, that was in 1987. We saw them in the productivity stats in 1995. Okay. So computers started in the 60s, 87, we were still saying, where are they? By 95, they showed up. And I think there's reasons to think that AI is going to have that same kind of progress. We're already seeing in the press frustration about, well, AI was supposed to change the world. Here we are 2 years later, it hasn't happened. And honestly, that's exactly what we should expect. So everything I've said so far is not a sort of out of the box prediction, but here's a real prediction, which is, 10, 20 years from now, it will have made a difference. Even though I wouldn't be surprised if 5 years from now, we don't see much at all.
But I think if I'm allowed, I will take a bit different point of view from you. I think we already see a big difference, like especially if looking at the time frame, it takes way less time to see the difference with AI compared to, for example, your example is computers or even the internet.
It depends who you talk to. So I think so too, but it's still not showing up in the productivity data. Okay. So like in a macro sense, we're still not seeing a productivity boost from AI. And ChatGPT was 2 years ago, or almost. It was November 30th, 2022. And so if it really was transformative, maybe we should have seen it. That said, to me, like it's going to take at least a year for any company to figure out how to use a new technology and adapt. So maybe it'll be faster. I'm hesitant to make a sharp prediction on that. But I remember so I was a grad student in the late 90s and the internet was a new technology and I was all excited about it. And, I was doing industrial organization and figured if I studied the internet, no matter what I found, it would be new, right? And, but then I was on the job market in 2002 and it was not uncommon for people to say, oh, it looks like you bet on the wrong horse. It turned out the internet wasn't really a thing. We had the dot-com crash. And even with what then seemed like an accelerated process, yes, we had the crash, but it was already clear, to your point, that yes, this technology was making a difference, even if it wasn't showing up in the data, and even if financial markets had overvalued some companies.
Speaking about grad students and productivity, maybe we have to ask our grad students how long it takes them now to make a work compared to, let's say, 3 years ago. But this is just kind of a joke.
Yeah. Well, it's true. Like that's a great point though. There's things that are really faster. Like I'm stunned by, second and third year graduate students publishing papers now, which did not happen when I started. But I think it also takes longer to really make a name because there's just more clutter out there.
Yes, agree. Okay, moving on from the future to the present, what is, in your opinion, the most pressing issue in social science nowadays?
Okay, so I'm gonna come down on 2 places. Okay, so the first, by revealed preference, it's clear that I think understanding the impact of new technology and how it changes society is really important. And the technology I'm focused on is AI. There's other ones out there. Okay, so that's pressing issue number 1. Pressing issue number 2 is sort of a macro social science point, which is reproducibility in the social sciences and in the sciences generally is a first order issue. And how do we both still generate new, truly novel ideas without trusting them too much on the first publication? is really important. And so like one reaction to reproducibility is to say, you know, we just have to increase the standards to get something published. But then once it's published, we believe it. I think that leads to a strange equilibrium. In contrast, being a little more skeptical even after publication and trying to think through creating incentives for replication, I think is first order important. And I don't think we have a good solution there.
I completely agree with you. If I'm allowed, I think it's even higher, a bigger problem, especially maybe in marketing. Like I think there's
yes. Well, there's been so reproducibility has two parts to it, right? There's the explicit fraud side of it, and then there's the maybe like a file drawer type problem. And
yes.
there's been a lot of high profile cases of both in marketing. I don't know if that's because we also have a couple of high profile people in marketing who are really dedicated to rooting out this problem. And so I agree that it's clear that it's an issue in marketing. I actually don't know if it's because we're better at looking or that it's a bigger issue. I think that's still an open question.
Time will show.
Yeah.
And speaking about time, what is your vision for our community, let's say 10 years from now?
I think there's a lot still to understand about how people make decisions. Okay, like, you know, what's my vision for our community? I'm like, well, I don't think we know very much yet. And so I'm excited to figure out as we consolidate information, as we take advantage of new tools. So I think there's a handful of papers now comparing the simulations in AI, let's say, on decision making to human decision making. And I think those are interesting for helping us understand humans. I'm not sure they're so interesting for helping us understand AI because the AIs we're using today are the worst AIs we're ever going to use. But I do think they help us understand. I think that's a new tool, and we're going to unpack things there. I think there's lots of other new tools. I'm just like beyond saying because there's so much we don't know. I think understanding human decision making is like going to be a very fruitful area of research.
That's very interesting. Just curious, if I hear you correctly, so you think in the future the AIs will be way better than they are nowadays?
Yes. Yeah.
That's very interesting because I think they're nowadays also not that bad.
They're not for sure. And there's but GPT-4, for example, is a lot better than 3.
Yes.
So if you go back 2 years ago, you'll see, or you can go back to the old version and you'll see, like it's surprising how fast it's gotten better. Now, there's another question, which is an interesting sort of IO productivity question, which is what's the threshold of of quality for usefulness?
Mm-hmm.
So yes, my digital, the camera on my iPhone is much better than the camera was 6 years ago. I'm not sure I get that much more utility out of it in terms of the overall experience. And so at some point, maybe we'll hit a threshold with these models that even though they are much better, it doesn't matter in terms of usefulness. But it's an open question whether GPT-3 was actually the right level for usefulness, or 4 or 5 or 6 will change that.
Yes, I completely agree. And this is definitely a marketing question. When do you stop to notice the difference with very many products?
Yeah.
I can't agree more. And what is, in your opinion, the most impressive finding from the last, again, let's say 10 years? You can go longer if needed.
Oh, that's a tough question.
Sorry about that.
No, I know. You prepped me for it, and I still don't have a good answer. So here's a few things that I'm a few new ideas that I'm excited about, and then we can sort of think through, I don't know, most impressive or not. So Acemoglu and Otter, about, I don't know, depending on how you count, 15 to 30 years ago, developed this task-based model of how, jobs work. So they thought of jobs as a series of tasks, And then you figure out the skills required to do those tasks. And then you can try to understand how work has changed through technology and regulation and other things as the tasks that humans do in work have changed. And I think that framework, that model has been really useful in understanding the short run impact of technical change. There's a as with any transformative model, there's some things that aren't there yet. And actually, a bunch of my work has been about what's wrong with the task-based model, but I still think that's a really fundamental contribution. And in the more on the decision theoretic side, the rise of these models, these formal models of rational inattention, there's been some competing, which one is the best one? I don't know, but just this, can we try to put some formal models on the brain on what to pay attention to and what not to, and calculate the cost in an explicit sense of inattention? I think those have been fantastic. I guess starting with Sims 2003, and then Xavier Gabay has a bunch of papers on this, and I think there's just a whole really interesting area of research, which is you start with a theory, then you show some interesting correlations and some data, and then ideally you figure out how to structurally estimate that degree of rational inattention. I think that's exciting, and I think it's open. I don't think anybody's done it truly, truly well yet.
Yeah, and I agree that in many cases, this information avoidance, you prefer not to know.
Yeah.
Like, especially in medicine cases, but not only medicine cases, even with pricing. Like, for example, if you bought something and now you maybe find out that you could buy it for cheaper, I'm not sure if you want to know.
Right.
There is a bunch of paper about it, I think, as well.
Yeah, absolutely.
And tell me, please, as a very accomplished and presumably young scholar, what is your advice for young scholars? Young, I mean by age, not your seniority.
Okay. No, not feeling so young these days, but so this is at the end of your career, if you've had one idea that's stuck, it's a successful career. And so, and almost nobody has more than one. And so that means that, let's say you have a new idea every year, or more than one new idea every year, the vast majority of what we do in our profession is failure. And so just getting used to being told no, sometimes because the other person doesn't understand and it will take time for your idea to percolate, and sometimes because it turns out that wasn't the right idea or wasn't delivered in the right way. And like just dealing with working for a long time and then being told no, and then being able to get back up and think the next idea, because ultimately, as I said, like a hugely successful career has one big idea. That's it.
That's a very interesting advice. I think it's very related also to publications. Like you try to publish anything, and then most of the time you just get rejected.
Right. Absolutely. So most of just there's rejection everywhere. There's you try to publish, most of the time you get rejected. You do publish and it makes no difference in anybody's life or anybody, nobody pays attention to it. You give a seminar and you get attacked for all sorts of things that may or may not have been fair. Like or worst case scenario, no one says anything in your seminar, and no one remembers it. So there's just a lot of rejection in this business, and that's okay.
Yes, even if you're not getting rejection, it's always, I'm not sure if always, but I think the feeling is that they're making you a favor. Like it's not a good paper, but you know what? Okay, you can resubmit it with this if you make all these 5-page changes, which with everything. So
for sure, yes. And then it gets published and maybe people pay attention and maybe they don't. So
Yes, so resilience, if I can summarize it in one
Yeah.
word, maybe.
Yeah.
I think you already told us a little bit about your books, but do you want to add anything because to what you said
No, I think
before?
I think I covered them pretty well. So prediction machines was this idea that, it's useful to understand AI's prediction. And then power and prediction was a summary, using that to try to think through the implications of AI as a general purpose technology. What was fun for, like, if this is to the extent that this is an academic type audience, both books had an initial like academic paper, typically relatively simple theory at the heart of them. In fact, both came from discussions at conferences and other places with Tim Bresnan, who's an IO economist, and a couple others. So they had this simple-ish theory idea at the center, and then sort of unpacked it through examples and through drawing on the rest of the literature. So that's a really fun way to write a book to me.
Cool. So I really recommend them for our audience. And do you have other recommendations for our audience? Which book will you recommend us to read?
So if you're interested in trying to understand how AI is going to affect our day-to-day life and like how to use it effectively, like as almost like a self-help book around AI, Ethan Mollick, his book Co-Intelligence is great for this. Just simple, practical advice on how to integrate these tools into your day-to-day life. And so, yeah, so we'll stick to that. Stick to what I know.
Cool. Avi, thank you so much. That was a great conversation. And I thank you for your talk and for your time now. And I
My
hope to
pleasure.
see you in the future.
Absolutely. Thanks so much. Take care.
Thank you.